Okay, in this video we are going to be looking at applications of quadratic functions that involve maximum and minimum. For example, if I throw a ball up in the air, the question would be what would be the maximum height, and also the horizontal axis might be time, so at what time does the ball reach the maximum height? So questions like that. All of them, all these ones are looking at quadratic functions, so they all have this parabolic shape, either that way or this way, and they all have a formula that you can write in this form. That's a b. Bx plus c, and so from this we can use our tools to try and find the vertex. So this whole section is all about the vertex and finding that. So here's some questions. Value of stock can be determined with this function there. That should be a squared up there. Where x is the number of months since the stock was created, and then v of x is what the value of the stock is. So the question is, when is the thing going to get to be the lowest number? So it's x squared minus 8x. Since it's positive x squared, I know it looks like this. So I'm looking for that lowest number. I'm looking for the vertex. So with this one you can find the vertex in a number of different ways. I'll just maybe with this one show you how you can do it with completing the square. So I can take and group the first two, and then I'm going to complete the square with them. So it'll be x squared minus 8x. Then I take this divided by 2 and square it. That gives me divided by 2 is 4 squared 16. Okay, if I add 16 out here on this other side, I have to subtract 16. Then in here, I've got x minus 4 squared, if I factor this. And I made it a perfect square, that's why I can do this. And then outside, 17 take away 16 is plus 1. So this is my vertex then will be the point 4 and positive 1. Notice to change that sign right there. So that point where the stock gets its lowest will be at 4, 1. So 4 is the x value, so it's got to be the number of months. So after the stock was created, 4 months after that, this thing will have reached its lowest point. And the lowest point that it reaches is $1 or 1 point or whatever stocks are. Okay? All about finding the vertex. Let's try another one. Family wants to maximize the area of their garden. Okay, so I've got to have area equals length times width. That's going to be involved. They have 100 meters of fencing to go around it. Ooh, that's a perimeter. What are the dimensions that will make the largest garden, to maximize the garden? Okay, you might just say, well, it's 100, so you probably want to split that up into a square. So 25, 25, 25, 25 on each side. That's probably going to be the maximum one, but let's just see. I know that the perimeter is 2 lengths plus 2 widths. But I know the perimeter, they have 100 meters of fencing to go around it, so the perimeter would be 100. So I have 100 equals 2 lengths plus 2 widths. If I divide everything by 2, just to simplify things a little bit, I get length and width are going to be 50. But I want to express this in just one variable. So I'm going to maybe move the L to the other side. So I'll go 50 minus L is equal to W. Okay, so this is what W is, but in my area formula over here, rather than writing W then, I'm going to write 50 minus L. 50 minus L. Okay, so now let's multiply that through distributive property, so I get 50L minus L squared. Let's write it in the proper order. Minus L squared plus 50L. Hey, I'm missing that C term. Oh well. So there's my quadratic function. It's a minus out front, so I know it's upside down like this one. And they're looking to maximize the area, so they want to know what that vertex is up there. Okay, let's use a formula for this one. So the formula says to find the value of the vertex, do two things. First, figure out what minus b over 2a is, and then take whatever you get from that and plug into this equation. So my first step will be this one. My second step will be to take minus L squared plus 50 times L. Whatever I get from this first part, I'm going to plug in right there. Okay, so minus b, b's 50, all over 2 times a is a negative 1. The negatives cancel, so and 50 divided by 2 will be equal to 25. So that point up there, 25, and in my equation it had L's, so 25 will be the length. And now, if I plug that back in, that'll tell me what the total area is going to be. Okay, so let's plug 25 in right here. 25 and 25. So 25 squared is 625, so it'll be negative 625 plus 50 times 25, I think is 1250. And if I add those together or subtract them, whatever, it comes out to 625. So the area of the garden will be 625 square, whatever, meters, feet, whatever we have there. Meters. Okay, one last question. What is the maximum profit of two numbers whose sum is 22, and what are the numbers? Again, I'm hoping to get a quadratic function out of this and then come up with a vertex for it. So maximum profit of two numbers whose sum is 22. Okay, so I've got to go a number times another number, and that's going to be a maximum. So let's just call that m. Okay, but these two numbers, it says, has a sum of 22. So let's call one of the numbers x. Then the other number has to be whatever the difference between 22 and x is. So the other number's got to be 22 minus x. So my first number is x times my other number, 22 minus x. That's going to be my maximum profit. Let's put a function to it, so maximum profit. Multiplying through, I get 22x minus x squared. Do you see the same game happening? Minus x squared will go up front, plus 22x equals that m of x. Now I've got a quadratic function, so now I can either complete the square or use the vertex formula to find it. I'll just show you completing the square just for fun. Let's take a negative 1 out, so it'll be negative 1 outside, and then x squared minus 22x. Now let's complete the square there. So I've got to take the minus 22 and divide it by 2, that's 11, square that, 121. So minus 22x plus 121. Now, this effectively subtracts 121, so outside I have to add 121. Okay, so now this I made a perfect square. It'll be x minus 11 squared plus 121 is equal to my m of x. And now I've got it. So my vertex is this point here, 11 and 121. So the number, that's the number up here, this number is going to be x. So the first number is x, and the first number is 11, and the next number is 22 minus 11. Oh, the next number is 11 too. Whoops. I should have said okay there. Yeah, so my first number is 11, my second number is 11, and the maximum product that they'll come out to is 121. Okay, hopefully that helps you with section 7.7 and max and min problems involving quadratic functions.